Welcome, my dear students. So, today is the third session of our Introduction to Engineering Mechanics. So, let us continue with our session. We will start from the principle of transmissibility of forces. Okay. So, what is this principle of transmissibility of forces? See, it states that the force acting on a rigid body acting at a point can be transmitted along its line of action to any point without changing the effect of force on the body. See, what I'm trying to tell is the force acting on a rigid body. So whenever a force acts on a rigid body, any change will happen? Nothing, right? Because rigid body definition is only it won't change its size and shape under the action of forces, right? If it qualifies that statement only, it's called as rigid body. The force acting on a rigid body acting at a point can be transmitted along its line of action to any point without changing the effects of force on the body. So, see the figure here. See, this is the rigid body. Okay, this is the rigid body. So, here the force F is acting at A. So, we will take a consider 2 points A and B, right? So, line of action means what? In the ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಆ ಫೋರ್ಸ್ ಹೋಗ್ತಾ ಇದೆಯಲ್ಲ ಅದನ್ನ ನಾವು ಏನಂತೀವಿ ಲೈನ್ ಆಫ್ ಆಕ್ಷನ್ ಅಂತೀವಿ, which in means if the force is going in this direction, so this is called as what? Line of action. This dotted lines or this green lines is called as what? Line of action of this force F, like that. See, so this is a rigid body. 2 points are there. 2 means A, 1 point is there A. Okay, so A is acted upon a force by F. So this F is the force acting on A. Okay, and its line of action direction is this one. No, so the line of action is this one. Okay, so whatever the effect is given by the force F on the element A, on the point A, on the same rigid body, the same force, the same effect would be at a point B that is in the same line of action. So in the same line of action ಅಲ್ಲಿ ಇದ್ದು ಆ ಫೋರ್ಸ್ ಏನಾದ್ರು ಆ ಲೈನ್ ಆಫ್ ಆಕ್ಷನ್ ಅಲ್ಲಿ ಆ ಫೋರ್ಸ್ ಏನಾದ್ರು ಬಂದ್ರೆ, ಸೊ ಇಲ್ಲಿ ಏನದು ಎಫೆಕ್ಟ್ ತೋರಿಸ್ತಾ ಇತ್ತು ಅದೇ ಸೇಮ್ ಎಫೆಕ್ಟ್ ಅದು ಬಿ ಅಲ್ಲಿ ಕೂಡ ತೋರಿಸುತ್ತೆ, ಅದರ ಅರ್ಥ. ಸೊ ಸಿ ದ ಫೋರ್ಸ್ ಆಕ್ಟಿಂಗ್ ಆನ್ ಅ ರಿಜಿಡ್ ಬಾಡಿ acting at a point can be transmitted. This force acting at A can be transmitted at B in the same line of action, okay, without changing the effect of the force on the body. Whenever this force is acting, whichever the force which is acting on A, whenever it is transferred at B in the same line of action, the effect will be same. Okay, the effect will not change in that rigid body. So see here in the second figure, the force is at B. Okay, the force is at B, it is transferred in the same line of action and the effect is also same. So this is called as what? Principle of transmissibility of the forces. That is, the force can be transferred from one point to another point in a rigid body in the same line of action without changing the effect of force on the body. Okay, this is the principle of transmissibility of the forces. These are all the basics which you need to understand to solve the problems which are coming in future chapters. Okay, next we will see the Newton's laws of motion. Okay, I know you already studied this Newton's laws of motion in your PUC, but we will refresh our memory. Okay, what are these Newton's laws of motion? We will see one by one. So first one is Newton's first law. So what it states? It states that every body continues in its state of rest or of uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. So whenever every body continues, what it states, every body continues in its state of rest. If this is a body, it is placed here, it will be in that state only for so many years. Okay, if it is not disturbed. Okay, if it is disturbed by some any force, then only it will tend to move, or it will shift from one place to another place. So this is the meaning of this Newton's first law. What is that? Every body continues in its state of rest. Okay, in its state of rest, or if it is in motion, it is continuous. It will be in motion only if it is in motion in a straight. Okay, if it is in uniform motion in a straight line, unless it is compelled, unless it is disturbed to change the state by forces impressed on it, it will not change. So a body, an action, or an agent is required to change its state of rest or of uniform motion in a straight line. So this is called as what? Newton's first law. Okay, we all studied in your PUC already. So it is also called as what? The law of inertia. Okay, it is also called as what? The law of inertia. This law furnishes us, so by this law what we will get? The definition of what? Force. This law furnishes us the definition of force, which acts as an agent that changes or tend to change the state of rest or of uniform motion of a body. So force can be defined as what? It is an agent that changes or tend to change, the state of rest or of uniform motion of a body. Is called as what? Force. So next we will see Newton's second law. It states that the rate of change of momentum is directly proportional to the impressed force and takes place in the same direction in which the force acts. So your Newton's second law, what is it states? It states that the rate of change of momentum, okay, is directly proportional to the force, impressed force, and it takes place in the same direction in which the force acts. Okay, so from this statement what we can expect? We can expect a formula for force, right? So we will assume some things. What is that? Let m be the mass of the body, u is the initial velocity of the body, v is the final velocity, okay, a is the constant acceleration. So what is a? Acceleration, the rate of change of velocity. So velocity by time is what? Acceleration. So time in seconds to change velocity. F is the force required to change velocity in time t. Okay, so these are our assumptions. So now according to the statements we are going. So what is the statement? The rate of change of momentum is directly proportional to the impressed force, and that takes place in the same direction in which the force acts. Okay, so what is the initial momentum of the body? So initial momentum of the body is mass into velocity. Okay, so initial, right? So what is the initial velocity? It is u. See here. Okay, so then final momentum of the body, what it would be? The final moment of the body is m into v, this one. So m into u is what? Initial velocity of the body. M into v is what? Final moment of the body. Then what we do? We do the rate of change of momentum is equal to what we do? We will, the rate of change of momentum, how it will calculate? It is nothing but final momentum minus initial momentum. Okay, final momentum minus initial momentum divided by time. If we do this, we will get the rate of change of momentum. Then this is proportional to what? Your force F. Okay, this is the procedure which we are going to do now. So the initial momentum of the body is mass m into u. So the final momentum of the body is what? M into v. Okay, now the rate of change of momentum is final velocity minus initial velocity divided by t. Okay, then m is common, m v minus u by t. Okay, then v minus u by t, velocity by time. Okay, either it is okay, output or what? Final velocity minus initial velocity, it will be velocity only. So velocity by time is what? Acceleration. So that is m into a. So rate of change of momentum is equal to what? ma. Now according to Newton's second law, this rate of change of momentum is directly proportional to what? Force. So ma is directly proportional to the impressed force in the direction of force, right? So that I written as this, F is equal to ma. Okay, when this constant term is turned into equality, then one constant of proportionality will come. and it is assumed as 1, so we can expect a formula that is F is equal to ma from our Newton's second law. Okay, next we will see the Newton's third law. This is well known law for all of us in our daily life, right? Newton's third law. What is this law? It states that to every action there is an equal and opposite reaction. So whatever the action we do, there is an equal and opposite reaction from the others, right? So what is Newton's third law? To every action there is equal and opposite reaction. That means when one object exerts force on other object as action, the second object also exerts the same amount of force on the first object in opposite direction as reaction. Correct? So this is your Newton's third law. So this was about the basic laws of the Newton. Next, another one law is there. What is that? Newton's law of gravitation. So here it states that two particles, okay, two particles, if we consider two particles, okay, I'll change the color. So first I'll read the statement. Two particles are attracted towards each other along the line connecting them with a force whose magnitude, okay, is proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay, see here, two particles are there. M1 is a particle, M2 is a particle. Okay, these two particles attract towards each other. Okay, these two particles are attracted towards each other along the line connecting them with the force. So whatever the force exerted by this M1 force, it is attracted by the F1 force, and M2 is attracted by the F2 force. Okay, the law of attraction is there in between the two particles. Okay, now connecting with the force whose magnitude, and its magnitude is proportional to what? To the product of masses. It's what is the mass of this M1, what is the mass of what the force magnitude means, the force value, the attraction value. The two particles are attracted towards each other, right? So that attracted value, the attracted quantity is what? It is the product of their masses and inversely proportional to the square of distance between them. Okay, see, so the distance between two particles is r. Okay, it is inversely means it is divided by r square. See, let m1 and m2 be the masses of two particles at a distance r between them, then force is equal to force according to this Newton's laws of gravitation, force is proportional to the product of their masses. Yes, it is product of their masses, m1 into m2 is product only, and it is inversely proportional to the square of the distance between them, and it is inversely proportional to the square of the distance between them. Okay, this much quantity of force is attracted towards each other according to the Newton's law of gravity. Okay, by remembering this picture only, you can write the statement. So if they ask Newton's laws of gravitation, what you can write? See this figure now. See, if two particles, we have to start from two particles, right? They are particles only. So do you remember this figure? Two particles are attracted towards each other. Whenever two particles are attracted towards each other along the line connecting between them, okay, these are attracted towards each other along the line connecting between them, whose magnitude, whose value is proportional to what? To the product of their masses, okay, to the product of the masses and inversely proportional to the square of the distance between that two particle is called as what? Newton's laws of gravitation. Then F is proportional to m1 into m2 divided by r square. When this proportionality is made to equality, then we will get a constant, that is what? G is the universal proportional constant. So the formula will be G into m1 into m2 divided by r square, where G is the proportionality constant. Okay, if a particle of mass m lies on the earth mass m and radius r, then the formula will be, if the particle of mass m lies on the earth of the mass m, okay, then the radius will be F is equal to, or weight is equal to mg, that is equal to g, it's a gravitational constant, m means particle size of mass m which lies on earth, m is the earth mass divided by the distance between that two particles, that is r square. So this is how we calculate them. Then g is equal to the small g, which we will take 9.78. How it is derived? By this formula only. G is equal to gm by r square, where g is what? Acceleration due to gravity. Okay. So g is what? 9.81 meter per second square. This is derived by or founded by this theory only. That is Newton's laws of gravitation. Okay. Next we will see the parallelogram of law of forces. 1 minute. Okay. So g is 9.81. Okay. So now we will see the parallelogram law of forces. So what is this parallelogram law of forces? So it states that if two forces A and B acting at a point be simultaneously represented in magnitude and direction by the two adjacent sides OA and OB of a parallelogram ACB, then the resultant of two forces R may be represented in magnitude and direction by the diagonal OC which passes through point O. See here, it states that if two forces A and B, see the forces A and B acting at a point, so they are acting at a from a point, right? So O is the point from where both the force are acting, and we named the force OA as what? F1, and OB as what? F2, right? So if two forces A and B acting at a point be simultaneously represented in magnitude and direction, so these forces, so two forces A and B, this is the force A and this is the force B. Okay, they are represented in a form of parallelogram in magnitude and direction. So what is the magnitude? Represented here A. What is the magnitude? It is represented here B. So force F1, okay, this is force F2. Okay, whenever we get this type of problems in future, we have to use what? Parallelogram law of forces. So OA and OB of a parallelogram, when we arrange them as to see as parallelogram, that is like OACB, then the resultant of that forces, okay, of the forces of what? OA and OB, okay, then the resultant of two forces R, then this resultant R may be represented in magnitude and also in direction by the diagonal OC which passes through the point O. So what is this parallelogram law of forces? If any two forces are there, ಎರಡು forces ಇದ್ದು, ಸೊ ಅದ್ರದ್ದು ನಾವು ರಿಸಲ್ಟೆಂಟ್ ಕಂಡುಹಿಡಿಬೇಕಾದ್ರೆ ಸೊ ಅವಾಗ ಆ ಫೋರ್ಸ್ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಪ್ಯಾರಲೋಗ್ರಾಮ್ ತರ ಅರೇಂಜ್ ಮಾಡಿಕೊಂಡು ಒಂದು ಫೋರ್ಸಸ್ನ OA ಅಂತ ತಗೋತೀವಿ, ಇನ್ನೊಂದು ಫೋರ್ಸಸ್ನ OB ಅಂತ ತಗೋತೀವಿ. ಸೊ ಅದ್ರ ರಿಸಲ್ಟೆಂಟ್ ಕಂಡುಹಿಡಿಬೇಕಂದ್ರೆ ನಮಗೆ ಅದರದ್ದು ಡಯಾಗನಲ್ ಫೈಂಡ್ ಮಾಡಿದ್ರೆ, ಡಯಾಗನಲ್ OC ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಸಾಕು, ಅದರ ರಿಸಲ್ಟೆಂಟ್ ಫೈಂಡ್ ಮಾಡ್ದಂಗೆ ವಿತ್ ದ direction also. So this is the summary of the parallelogram law of forces in Kannada. Okay. See, this implies that a force can be represented by a straight line with an arrow as a vector. Yes, force should be represented by a straight line with an arrow as a vector. So where you show the arrow, no, so that is the line of action. In that direction is the line of action. See, let F1 and F2 be the two forces acting at a point 4. See here, let F1 and F2 be the two forces acting at a point O. Let OA and OB be the two forces F1 and F2 respectively, both in magnitude and direction. Magnitude means its value and direction means its line of action. That is like this. OA is like this and OB is like this. Okay, two forces are there. This is what? F1 and this is what? F2. Now what we want? We want the resultant. So questioner is asking, examiner is asking to find the resultant of the two forces. Then we have to arrange them in this parallelogram like this. Okay, wait. Then the resultant R can be found out by the resultant R of F1 and F2 can be obtained by completing a parallelogram. We have to complete it. So we have only drawn this much. Oh, wait, I can show you this much only. That is F1 and F2. We have to complete it by the, we have to complete it like this. Okay, completing a parallelogram with OA and OB as the adjacent sides, with OA and OB as the adjacent sides of the parallelogram. The diagonal OC, if OABC remaining is this one, right? The diagonal OC of the parallelogram represents the resultant R both in magnitude and direction. The diagonal OC, so this value gives us the resultant force from the value F1 and F2. F1 and F2 in the borrowed resultant value na, the resultant R will give, which is the diagonal of the parallelogram OACB. Okay, so this was about the law of parallelogram of forces. See here, we'll solve it, we'll prove that. So let us consider two forces, that is P and Q. Okay, simultaneously acting at a point O, be represented A along the sides OA and OB respectively of a parallelogram OACB. Let OC be the diagonal. Drop CD to OA extended. Okay, we should drop so here we will drop CD to make the OA extended. Okay, so this is our figure. Okay, see here we have to drop CD. This is a straight line, so I am drawing from the mouse, so it is adjust to that. So this is a straight line. Okay, so now what we can do, so we need to find what the resultant of the forces. What is that? P and Q. So the P and Q are the two forces, so we arranged in this parallelogram. So they have given two forces, that is P and Q. So this is P and this is Q. Oh, they both are acting at both that are simultaneously. Okay, so they give such type of problems in which they will give two forces, that is like P and Q, and they are starting or they are meeting at a point O. Then we need to find the resultant R. In such cases, what we have to do, see here. So I'll take the forces P as a side of a parallelogram, that is OA, that is P. Okay, I'll take this force Q as OB as a side of a parallelogram OB. Okay, that is this one. Okay, OA and OB I took as the sides of the parallelogram. Then I need to construct it to a parallelogram. So dotted line is the construction. Okay, so once it is constructed, then it is called as what? The parallelogram OACB. Okay, this is the parallelogram OACB. Now what we need to do, we need to drop a line CD to make the line OA extended. Okay, to solve the purpose. So from triangle OCD, so from triangle OCD, okay, from triangle OCD, what we can expect? So by the Pythagoras theorem, what we can do? So this hypotenuse, this OC square, okay, this OC square, that is OC square is equal to OD square. So this is D, right? Okay, OC square is equal to OD square plus CD square. Okay, this is CD. Okay, by the Pythagoras theorem, this OC square is equal to OD square plus CD square. Correct? Now, but what is this OD? Okay, 1 minute. I'll draw a permanent line here. So this red line mark is the permanent line. Okay, I drop the, this is CD. Okay, see. Now, what is OD? OD is nothing but OA. See here, this OA plus AD. Okay, OD is nothing but addition of OA plus AD square. Okay, plus CD whole square. So OA plus AD whole square is how it is. It is A plus B whole square. So OA square plus AD square plus 2OA into AD plus CD square. So A square plus B square plus 2AB plus this CD square here. So I will take this equation as 1. This is from the triangle OCD. So now from the triangle ACD, here from this small triangle. Okay. See, in this equation, what I know, in this equation 1, I know the value of OA. What is that? It is value that is P. Okay. In this value, I don't know the value of AD. Now I want this AD. So from the triangle ACD, I take down this triangle ACD. The value of AD by AC, that is this value AD by AC, this dotted line. Okay, this is hypotenuse, this is adjacent. So adjacent by hypotenuse, what is that? Cos. So what is that? Degree. Cos alpha we will take. So AD by AC is equal to cos alpha. Correct. So what we can write the AD as, AD is equal to, see, AD by AC is cos alpha. If I want AD is equal to AC into cos alpha. AD is equal to AC into cos alpha. What is AC? See here, this is AC, this green line. So this purple line is what? AC. Okay, AC. But this AC is equal to what? This AC is equal to what? OB. Okay, this AC is equal to OB, and this OB is equal to what? Q. So we written as AD is equal to Q cos alpha. Similarly, we want the value of CD also from this triangle only, that is triangle ADC. We can also find the value of, from this triangle ACD, CD. What is that? CD, that is opposite side by hypotenuse, is what? Sin alpha. Okay, so CD by AC is equal to sin alpha. So CD is equal to what you can write? AC into sin alpha. Your AC is also equal AC. So this is AC. AC is equal to what? Your OB. So that is Q sin alpha. So CD is equal to Q sin alpha. Correct? So just I constructed a triangle in side to the parallelogram, so that I got the value of AD and CD. If we substitute the values, we are getting R square is equal to P square plus Q square cos square alpha plus 2PQ cos alpha plus Q square sin square alpha. So what is this P square? We are returning the same Q square. So this cos square alpha, sin square alpha, we are taking a term. So Q square is common, sin square alpha plus cos square alpha plus 2PQ cos alpha. Then P square plus Q square plus this is equal to what? Due to the, from the mathematics, it is sin square alpha plus cos square alpha is equal to 1. So we are getting this R square is equal to what? P square plus Q square plus 2PQ cos alpha. What we did? We just substituted the values of this OC square. OC square is what? This R square. So R square is equal to what? OA means what? This OA is nothing but P square. Okay, this is P square. AD square means what? This is Q square cos square alpha plus 2OA 2P square. AD means what? Q square cos square alpha plus CD means Q sin square alpha. Q square sin square alpha. Just I substituted, I'll get these values. Okay, then we are getting the values of R. What is that? R value is square root of P square plus Q square plus 2PQ cos alpha. This is the value of the resultant R. So once we find the resultant, we need to find the direction also. So let theta be the angle made by the resultant R with P. Then tan theta is equal to what? So tan theta is equal to opposite by adjacent, that is CD, this term CD divided by OD. Okay, but what we know, OD is equal to what? OA plus AD. So we know the value of CD from the last slide, that is Q sin alpha, plus P means what? P, plus we know the value of AD, that is Q cos alpha. So here whenever two forces are given, then they tell us to find the resultant and also the direction of that force, then we need to use these two equations, that is r is equal to square root of p square plus q square plus 2pq cos alpha, and tan theta is equal to q sin alpha divided by p plus q cos alpha, to find the magnitude and direction of the resultant whenever two forces are given in future. So this is how we solve the problem by using the parallelogram law of forces. So these are the formulas which you need to remember, very important formulas. Okay, so by this I conclude this today's topic. For that, see here different cases of parallelogram. So whenever theta is equal to 90 degree, so in this equation only, when r is equal to root of p square plus q square plus 2pq cos alpha, and tan theta is equal to q sin alpha divided by p plus q cos alpha. See, this is your homework, we have to do this. Okay, so whenever theta is 90 degree, just you have to do in the place of theta, means here they have taken, they have given their value. See, theta is this one, okay, alpha is this one. Whenever theta is 90 degree, okay, so what is the value? R is equal to square root of f1 square by f2 square. Okay, because what happens, see here, so here in this picture, alpha is this value, theta is this value. Okay, you just note it down the formulas. Thus R is equal to p square plus q square plus 2pq cos alpha, right? But what in this figure, what it happens? So here what it happens? So R square is equal to, so I directly taken as R square only. So p square plus q square. No, wait, right? So it is, I'll show you in the same way. R is equal to square root of, instead of p they have taken as f1 square. So f1 square, okay, plus f2 square plus, okay, 2 f1 f2. So this is the formula they have used, means same formula, just attributes are changed. As f1 f2 here cos, see the angle is what here, cos alpha, this is theta. See here the angle is what, theta, but we are getting the full value, that is alpha we have to take, right? So here what we are taking, wait, here what we are taking, cos theta. So this formula you need to use. R square is r is equal to square root of f1 square plus f2 square plus 2 f1 f2 cos theta. Okay, so when theta is 90 degree, cos theta, cos 90, how much? Cos 90 is what? Sin 0 0, sin 90 1. So cos 0 1, cos 90, yes, it will become 0, and cos 0 is 1, cos 0, it will, that term will become 0. So r is equal to what? Square root of f1 square by f2 square, and alpha is equal to what? So alpha is here, this alpha, tan inverse of f2 by f1. Okay, so concept is important. Here terms are changed, just you follow this method. So when theta is 180 degree, okay, r is equal to f1 minus f2. So you try to solve this. Okay, when theta is 0 degree, what is the value of r and what is the r value of alpha, considering this diagram. Okay, considering this diagram. So just the terms are changed, that's it. Okay, here instead of p they have taken as f1, instead of q they are taken as f2, and here what we solved, here it was theta, here it is alpha, here little change, no problem. Okay, just understand the concept, fine. So here I conclude this session, and the next topics will be dealt in your next sessions. Thank you, have a good day.